We are the Knee Brace Performance Study Group. My name is Derek Lewis.
I'm Matt Eisenhut.
I'm Devin Mullen.
I'm Brian Thorpe.
Knee braces are primarily used by athletes for support and pain relief. Some braces are big and bulky while others are very streamlined. The question was if we could identify a brace or a set of features that had better performance data than another brace. The result of this study could aid anyone looking for a brace in finding the best one for them.
The objective of this study was to run a set of braces through performance testing and rate them on their respective results.
The key questions of this study are: how does wearing a knee brace affect performance? Are there specific features of a knee brace that affect performance? And how do the materials of the brace affect performance?
We settled on 4 tests to run for our study. The first 2 being speed and mobility as an individual can be evaluated on those alone. The material properties of each brace were tested for their inherent support properties, and the comfort of each brace was taken into account as the gear worn by an athlete directly affects performance.
Each participant ran 4 sprints. Time was recorded for each. The control group ran every trial with no brace to find the change in time from completing the experiment. The experimental group ran once without a brace and once with each brace. Order was randomized for each participant. Squat testing involved each participant completing 4 sets of squats. The depth of each rep was measured as the angle from the thigh to the calf regarding 0 degrees as a straight leg. Participants were asked a series of questions about each brace to get a census on how each brace felt when worn. Deflection testing involved placing each brace on a bench top and clamping it in place. Weights were then hung a specific distance from the table edge to find the tip deflection values.
The generic equipment used in the experiment includes a tape measure, a ruler, a protractor, several kilogram masses, stopwatches, cones, and C-clamps. The braces were all sourced on Amazon and were chosen for specific features. Brace 1 was chosen because it is the smallest and simplest. Brace 2 is slightly larger and can put a higher degree of compression on the knee, as it can also be tightened in the back. Brace 3 is almost styled as a recovery or suspension brace, but it maintains a large degree of motion. It also provides the greatest leverage against a force to the side of the leg.
The run and squat trials both contained 3 data values for each trial. The values were averaged to reduce error. The initial values for deflection were subtracted from each weighted measurement to standardize the data.
The initial plan was to have the test plan finished during the week 4 section of class. We later found out that we would need approval from the university to run the study. The proposal was submitted in week 5, and we heard nothing back until the end of week 6. In that time, we finalized the test plan. The day after we had approval to run the study, we had 7 volunteers that were willing and able to participate. 24 hours later, testing was completed.
The total cost of the study was $172. The cost all went to the braces as all the other materials were available in the lab room.
Our group completed an IRB proposal in order to ensure that no participants in the study were at increased risk of injury, and to ensure that we were informed as researchers in how to mitigate risks. The study had a very low risk of fall or cardiovascular episodes. Every participant was screened beforehand to ensure that no previous injuries or underlying illness would increase their risk.
The analysis of the raw data starts at the control group. The run time for each participant's first trial is taken as 100%. Each consecutive trial time is divided by the first trial to find the percent change. The results of this show how, on average, performance changes over the course of running the 4 trials. The experimental group data is normalized in the same fashion, except that the 100% value is the trial with no brace, and each trial with a brace is calculated as percent of unaided no brace performance. The brace order for each participant is randomized. To find the change in performance solely from the braces, the percent change for each trial in the control group is subtracted from the respective data in the experimental group. The final results show that when fatigue is factored out of the trial data, each brace performs identically. The data for each participant was averaged in terms of each brace, showing that every brace has the same 98.6% performance when compared to their unaided time. Individually, participants all had a brace that they clearly ran the best with, suggesting that the performance of each brace is dependent on the user.
The data for the squat depth trials is normalized in the same fashion as the sprint trials. The no brace data is taken as 100%, and the data of each brace is taken as a percent, resulting in percent of unaided no brace performance. The results show that the brace 3 is the least constant and most dependent on the user. Braces 1 and 2 perform better, maintaining the greatest mobility of the wearer.
Deflection data was plotted to find the trend lines. The results show an extremely linear trend in a distance over mass plot. This suggests that the hinges act as springs with a linear force to deflection relationship. We chose to turn the data into a spring constant of each brace, using the constant as a rating on how supportive each brace is. The data showing that braces 2 and 3 performed better than brace 1, showing a greater support in the transverse axis of the knee.
The survey data shows that when participants were directly asked about how each brace fits and feels, brace 2 was the best. This data does not match our physical testing, as in most cases, the braces performed similarly. This data suggests that human performance is much less dependent on comfort and feel than assumed.
Over all trials, Brace 2 shows the most consistent results, suggesting its performance is not user-dependent. Braces 1 and 2 perform the best in mobility, suggesting that a compression sleeve design better aids ability.
Error can be reduced by increasing the number of participants in the study. The uncertainty of the data was reduced by recording multiple values for each child, averages taken from measured data.
If we ran the experiment again, we would test more braces and have more people in the study. With more data, we could better identify which features of a knee brace had the least detriment to performance, enabling us to design a brace ourselves and test it against commercially available products.